Alright, so welcome to the next video on the next section. Um, of so you probably already knew, but just in case you didn't, angles are measured in degrees. It just tells you essentially how far away the two rays are from one another, and the further away that they are from one another, then the larger the angle, and thus the more number of degrees that it would have. Angles in this class are going to be classified into four categories. We have what are called acute angles, which I'm sure that you've heard acute angles before. So the amount of degrees between those two rays is how is the size of the angle, the measure of the angle. So for acute angles, your measure is between 0 degrees and 90 degrees. And we put this little circle thing to indicate that's in degrees, to indicate the unit of measure. So it's got to be larger than 0 degrees. If this was 0 degrees, then you'd have like your first ray right here, and then your second ray would literally be on top of it because it didn't move anywhere upward because it's 0 degrees. That wouldn't be a ray anymore. That wouldn't be an angle anymore. That would just be a ray. And then it's got to be less than 90 degrees. It can't be. It's got to be less than 90, because if it's equal to 90, then we classify it as a right angle. So right angles, the measure of those angles are exactly 90 degrees. You can't assume that something, just because something looks like it's a right angle, you can't assume that it is a right angle. They have to tell you, or you have to be able to show in some way that it is a right angle without just assuming it. Now for a right angle, notice how it's got the little box thing right here? That's kind of a quick way of indicating that's a right angle whenever you see that box, rather than continually having to write 90 degrees there. Obtuse angles. So if you are larger than 90 degrees, then you would be an obtuse angle. So for this class, obtuse angles are going to be between 90 degrees and 180 degrees. So that would be an obtuse angle, like this one is clearly larger than 90 degrees, but also less than 180 degrees. And a straight angle would be exactly 180 degrees for a straight angle. So if I want to know like how large that angle is right there, and you're like, well, where's the vertex? Where's that point? Well, you could make that the vertex right there and say, okay, there's one ray, and then the other ray is going in the exact opposite direction. They're like opposite rays. Then that angle is thus 180 degrees for a straight angle. Next page here. Congruent angles. Congruent is kind of like equals that you learned in algebra, or I guess before algebra. But congruent angles are when they're the exact same size. We don't say that they're equal to each other. In this class, we say that they are congruent. So congruent angles have the same measure, meaning that they have the same number of degrees. So angle A here is 30 degrees, and angle B here is also 30 degrees. And notice how I just put those two markings on them? Those are called tick marks, which we'll be talking about kind of at the bottom of this page. But those tick marks thus indicate that these two are the exact same size. Or you can use like different kinds of tick marks to indicate that those two are congruent to each other. If you have more than one set of angles that are congruent, you can throw like little lines in there. There's all kinds of stuff that you can do to indicate that these two are the exact same size. As long as you have the same two things on tick marks on the two angles, then you're good. So angle A and angle B have the same measure. So the way we write this is we say angle A, and I have to put that little angle symbol in front of it because otherwise I'm talking about point A if I just use a single capital letter. And then to indicate congruent, it's like an equal sign with a little squiggly on top, or like a little tilde up on the top. That symbol in this class, that's the symbol for congruent. Like I said, it's kind of like equals. It just means that these two are the exact same size. They have the same measure. So angle A is congruent to angle B is the way that we would indicate A and B are the same size. Congruent segments. So not only do you have congruent angles, you can also have congruent segments. So like AB here is 5 centimeters and DC here is also 5 centimeters. They are congruent to each other. They have the same length. So since these two have the same length, we indicate, we can write that AB, that segment, is congruent to segment BC. It doesn't really make sense to say that two lines are congruent to each other, right? That doesn't make any sense because lines go on forever, so how can they be the exact same size? Like they go on forever. That doesn't make any sense. But segments, that makes sense. You can also use tick marks to indicate congruent segments. Like a lot of times we put like one tick mark on each of them to indicate these two are congruent, or you can put 2, or you can put 3 or 4, or you can put little triangles on them, or something to indicate that those two are the exact same length. So, this picture, I've got some tick marks on this picture, and I want us to say, well, which segments are congruent to each other and which angles, based on only the tick marks here, are congruent. Now, you can't, if it doesn't have the tick marks, you don't know that they're congruent. I know that the segment A to B looks the exact same size as it is to D to C, but I'm not going to say that those two segments are congruent because there's no markings there to indicate that those two are congruent. So based on the markings, the ones that I can see are congruent is I could say like segment AD is congruent to segment BC because they each have the one marking there. And I want you guys to come up with the second set of congruent segments that are marked up there. Congruent angles, and remember you need to be pausing the video, right? Don't just let me go on without you actually writing it down or else you're going to miss vital information. Seriously, pause the video and write it down. Congruent angles. Alright, so the angles that are marked congruent here, I see this angle and this angle are marked congruent, so I gotta be careful how I call those angles. You can't just call that angle X, right? There's a lot of angles that have that as the vertex. Like if you say angle X, I don't know if you're talking about this angle X, that whole straight angle X, and then there's a whole bunch of other ones like that, okay? Not those ones. You need to use 3 letters there. So I could call this one on the left angle AXB if I want to. That's not the only way to do it. You could have called that angle BXA if you wanted to. As long as X is that vertex angle, then I think we're probably good. And then at this other angle, how could I name this angle over here? I could call that angle starting at D and then going to X and then hitting C. Again, X is that middle letter there because it's the vertex angle. Okay? I want you to come up with the name of the other 2 angles that are marked up there that we know for certain have to be congruent to each other. And go ahead and write that in there. I think we are on the next page. So given that this is a right angle, okay, so they're saying we're giving you all this information. Based on all this information, this is what I want you to tell me. This is what I want you to figure out. So they tell us angle XYZ is a right angle. Notice how they put the little box there for us? How nice of them to put in that box for us. So angle XYZ is a right angle. That means that that entire angle there has to be 90 degrees. And then they say angle 1 is 3x, angle 2 is 12x plus 15. Now for me, it's really helpful for me on my homework to actually draw the picture out. Yes, you do need to have work shown on your homework. I'm not going to be accepting your homework unless you have work. Now I know that 1.1 there wasn't a whole lot of work to show because it was just naming angles and stuff. But like on a problem like this, yes, I do expect that you have some kind of work written down. You should have the picture drawn. You should tell me what it is that you're doing. You should give me the answer that you came up with. If I come around and all you have is just an answer down, don't expect any credit for it. Okay, I don't care what the answer is. Honestly, I don't care what the answer is. I am more interested in, did you know actually how to do the problem? On your tests, if you just have an answer written down and you don't have work where you should be showing some work, I'm not going to give you any credit for it. You need to have the work actually written out to get the credit for it. And you know what else? Here's a really good tip for you. Any math class, on any kind of test, quiz, homework, you should be writing out work anyway, because if you make a mistake and you have work there that's correct, you will get partial credit. You will get a higher test score than if you just have down a bunch of answers. Because if you have a bunch of answers and there's no work to go with it, one, I have no idea how you came up with those answers, and two, if any of them are wrong, then I can't give you any partial credit for it. Just a little hint. Okay. So back to this one. Angle 1 is 3x. I'm going to mark that down. Angle 2, this one is 12x plus 15. So what do I know about the relationship between 1 and 2? Well, remember the first given? They said that this whole angle right here is 90 degrees. So whatever angle 1 is, and whatever angle 2 is, those two together, added together, must total this entire angle of 90 degrees, right? Doesn't that make sense? That angle 1, this angle right here, if I put that together with this angle over here, those two put together should total this entire angle, which we know is 90 degrees. So that's how I'm going to set this up. So angle 1, which is 3x, plus angle 2, which is 12x plus 15, has to total up to 90 degrees. Oh, this is so exciting. It's our very, very, very first actual math problem in math class. Combining up my like terms, those two together give me 15x. Subtract off the 15 on both sides, and divide by 15, you're going to get a 5. Now, I may have moved through that kind of quick for you. Then pause it as I'm going through each step and write them down and see if you can't track along. If you're not tracking with me, you're not really getting anything out of this. Be hitting the pause button as often as you need to, or the rewind button as often as you need to. Now, this is very, very different in geometry than it is in Algebra 1-2. In geometry, in Algebra 1-2, you'd be done. You're like, oh, I solved for x. That's what we do in all of algebra, right? You solve for x and then you move on. In geometry, you've got to be really, really careful. You need to make sure that you are reading the question. The question's not asking find x. Sometimes it does, but here it's not asking you how big is x. It's asking you find. Now this little m right here, all that means is the measure. It's nothing fancy. They're just saying find the measure of angle XYW. That's what we need to solve for. How big is angle XYW? You need to go back, you need to look. X, Y, W. Oh yeah, that's like angle 1. They want me to tell them how many degrees that angle is, not how big x is. So I need to go back, I need to plug in a 5 back in for x in that angle, and that angle has to be 3 times 5, or that would be 15 degrees is how big angle XYW is. There's your actual answer. Next one here, parts of a degree. So kind of like the way that dollar bills can be broken into change, degrees can also be broken into minutes and seconds. It's also kind of like time. Like if I said to you, oh, put this in the microwave for, I don't know, you could say put this in the microwave for 20 minutes and 15 seconds or something like that. You can talk about that. Or I'll see you in an hour and 30 minutes from now. Like you can take these parts and break them into smaller pieces rather than having to continually say, I'm going to see you in 1.5 hours or I'll see you in 1.23 hours. Like you can break it down into just how many minutes that's equivalent to, or even go down to the number of seconds. So each degree is divided into 60 minutes, and it's indicated by this little symbol right here. Okay, that's just the one little marking. That's like a colon kind of a thing. That means that's minutes. And then if you've got the 2 markings, okay, or it looks like like one quotation, then that's for indicating seconds. But each minute thus has 60 seconds, just like in time. Like in time, 1 hour has 60 minutes in it, and each minute has 60 seconds in it. It's the same idea with degrees. Like rather than me saying, oh, this is like 1.5, or this is 20 degrees, and then another like half degree afterwards, I can break it down into 20 degrees and so many minutes, and if I want to get down to the little bits of a degree, then I can also talk about the seconds of the degree. It's just parts of degrees. So every 60 minutes gives us one, or every degree is made up of 60 minutes, and each minute is made up of 60 seconds. So to convert from degrees to minutes here, so 27 and 1/4 degree. I have a little part more, kind of like if it's been 27 hours and a fourth more of an hour. Like we don't say it's 27 and 1/4 hours, we would say it's 27 and so many minutes. So let's figure out how many minutes that is together.